In this video, I am going to talk about properties of limits. Let's consider these two limits. Limit x approaches some value a, f of x, and limit x approaches a, g of x. And we are making the assumption that both of these limits exist. So limit exists. And let's consider a constant c. Now, the first rule to remember is this. Limit x approaches a, f of x plus g of x is going to be equal to limit x approaches a, f of x plus limit x approaches a, g of x. What this says is this. Limit of sum of two functions, which is the left-hand side. Limit of sum of two functions is equal to the limit of the individual functions added together, or equal to the sum of the individual limits of these functions. Now, this is for addition. Now, for subtraction, this rule holds as well. So you just put a minus sign here, and this is going to be minus. So this is the addition and subtraction rule for limits. Now, the second rule, or technically kind of like the third rule, is going to be this. So let's consider the constant c. So limit x approaches a, okay, c times f of x, okay, c is the constant, is equal to, you can pull the constant outside, c times the limit x approaches a, f of x. So that means technically you kind of know this thing, like c is a constant, right? It does not depend on the changes in values of x. C is a constant just sitting down there, so it should not influence the outcome of the limit. Whatever the limit is going to be the same. Since you multiplied c by the f of x, here, right here on the left-hand side, you can pull out the c from inside the limit. Now let's talk about the third rule that involves product. So limit x approaches a, you have two functions, f of x and g of x. You multiply them and take the limit of this product, which, by the way, is going to be limit x approaches a, f of x times the limit x approaches a, g of x. So this formula or this rule says that limit of product of two functions is the same as the product of the individual limits of these functions. That's what it says. If you translate it into ordinary English, this is what it means. Limit of the products is the product of the limits, right here. The next rule or next property is, of course, after multiplication comes division. Limit x approaches a, f of x divided by g of x. Limit x approaches a, f of x divided by g of x is going to be equal to limit x approaches a, f of x divided by limit x approaches a, g of x. So this is the quotient rule. However, a very important thing to keep in mind, the denominator g of x cannot be 0, okay? We are making the assumption that limit x approaches a, g of x is not equal to 0. As a matter of fact, I would take caution here whenever I am involved in division, or whenever you are doing division of one function by another, make sure that the denominator does not evaluate to 0, because then you're dividing by 0, and in that case what happens is you come up with something undefined. So this quotient or the ratio of these two functions becomes undefined. So just make sure when you're applying the quotient rule, ensure that the function that you're dividing by, it doesn't have 0 values, okay? Just to avoid any kind of unexpected behavior. The next rule is this. It involves exponents. So limit x approaches a, f of x raised to the power n is going to be the same as limit x approaches a, f of x, and you're going to raise the whole limit to the power n. So this is what it says. The limit of a function raised to the power n is the same as the limit of the function raised to the power n. That means you can kind of like bring the limit notation inside and it still would be the same. It won't make a difference. The next rule would be this. Limit of x approaches a, nth root of the function f of x. Nth root of the function f of x is equal to nth root of limit x approaches a, f of x. Again, here, kind of like division, you have to remember something. N is a positive integer here, right? N, a positive int. Now, you don't have any problem if you have odd n's. However, for even n's, if you're taking square root, you have to make sure that your function evaluates to positive value, or f of x is greater than 0, or greater than equal to 0, I guess. So that's something you may want to keep in mind. But if n is odd, you don't need to worry about it. If n is even, though, if your f of x is less than 0, in that case, you're dealing with complex numbers. So that means we are talking about complex functions, which is not the topic here. We are talking about real functions of single variable. And then there are a couple of other simple rules which you can kind of keep in mind maybe. Number 7, which is this. Limit x approaches a, x to the power n is equal to a to the power n, all right? Or limit x approaches a, nth root of x is equal to nth root of a. These two are derivatives of this and this. So you really don't need to memorize this or anything. Just remember the first 6 rules, then you should be all good to go. And maybe yet another one. 9, limit x approaches a, some constant c like this one is just going to be c, because c does not depend on x in any capacity, so it should not have any impact if x changes. So these are the properties that you may want to remember. I hope that this discussion on limit properties was helpful. Thank you very much.